Okay, optimization problems, same type of business. We model it, we write an equation into a function, and then we find the derivative and set equal to 0. Simple as that. Sometimes taking the derivative can be a little bit more difficult. You'll see the example here. It says a rectangle is inscribed in a semicircle with a radius of 16. Let's put it on the coordinate plane. That sometimes seems to make things a little bit easier. Okay, so if I have a semicircle, that's my semicircle, and what I'm going to do is I'm going to put a rectangle inside of it. So this seems really similar to the problem we did the other day, right? But there are a couple little glitches here. First of all, this coordinate right here, x, y, and this one would be, negative x, y, right? And we want to maximize the area, so I need to write down the area is equal to length times width. What do you want to call or you guys like base times height better? Because sometimes people get confused with the length times width. Let's do base times height. What's the length of the base? Very good. So that's going to go in there. 2x will go in there. Now the height, we had to be able to express a function value, right? So I need something written in terms of x. F of x. What is f of x? Equation of a circle, right now we have a semicircle. So we're going to have the positive portion of the semicircle. We have x squared plus y squared is r squared. Maybe you remember this. And so if the radius is 16 in this case, then the equation would be x squared plus y squared is equal to 256. So that's the equation for the circle. We only want the top half of it. So do we solve for the positive portion or the negative portion? The positive. So let's solve for y so we can get a value in terms of x. And we have y squared is equal to 256 minus x squared. Now what? Square root. And when you square root, you have two values. You have y equals plus or minus the square root of 256 minus x squared. No, you can't take square root of both. You have a minus sign in there. So we want the top half. If we were to graph those on our calculator, the top half would give us, the positive would give us the semicircle on the top, negative would give us the semicircle on the bottom. So let's take this for our height, and we'll plug in the bottom portion, or the top portion, which is the square root of 256 minus x squared. Yes. Yep, very good. Yep. So we have area in terms of what variable? X is equal to 2x times the square root of 256 minus x squared. Oh boy. All right, let's do the derivative. If you're going to do the derivative, you have to use the product rule followed by the chain rule. Yes, very good. Let us find the derivative. What's the derivative of 2x? Times the second part left alone. 256 minus x squared plus 2x times the derivative of the square root of 256 minus x squared. For that, I need to use so I'm going to make some space here, 256 minus x squared. So I have u to the 1/2. What's the inside part? 256 minus x squared. Derivative of u to the 1/2. Good. Derivative of 256 minus x squared. Multiply these, you get negative on top, right? X on top over the square root of 256 minus x squared. Square root in the denominator. Only if it contains a variable, it's okay. Everybody understand how I got my derivative? Okay, now we're going to put that back with this. So we're going to multiply by negative x over square root of 256 minus x squared. And we're going to set that equal to 0. So we'll just write it out one more time, and then we'll solve it. 0 equals 2 square roots of 256 minus x squared minus 2x squared over square root of 256. How's that? And again, all we're doing right now is algebra, so. But it's, algebra, well, yeah, we all know now, algebra gets difficult. So next time you say, oh, I love algebra. Well, algebra can be challenging. So, algebra 6. This is calculus. Okay. If we set that equals 0, let's, we got 2x squared on top. We got square root of 256 minus x squared on bottom equals, on the other side, 2 square roots of 256 minus x squared all over 1. What should I do? Cross multiply. 2x squared equals 2 times 256 minus x squared, right? Yeah, 2 times 256 was 512. And then minus 2x squared, right? When you multiply the square roots, they'll go away, yep. So you have 2 times that 256 minus x squared then, yep. Shh. Okay, hold on, we got 3 questions here. First, second. Okay, another question? No? Okay, so then we add the 2x squared over the other side. We get 4x squared is equal to 512. Divide both sides by 4. Very good. X squared equals 128. Uh, 8 square roots of 2, right? People, we could take out a 64. So, we have that part, 8 square roots of 2. That tells us x. So x is 8 square roots of 2. If we plug 8 square roots of 2 back into 2x, what do you get? Good. So the base is equal to 16 square roots of 2. And now the height, we plug that 8 square roots of 2 back into here. You know what you get? Well, what do you get when you square? What do you get when you square 8 square roots of 2? 128. 256 minus 128. 128. Square root of 128. 8 square roots of 2. And if you just want to convert it to a decimal and plug it all in, you're fine. But if we square 8 square roots of 2, we get that 128. 256 minus 128 is 128. We already established the square root of 128 is 8 square roots of 2. And so that's the dimensions of the rectangle that would maximize the area. Okay. This one's really not that hard. Okay. This was really not that hard at all. Okay. But this is a little bit different type of problem. Okay. It says find the equation for the line tangent to the curve that has the largest slope. That has the largest slope. So let's think about this. Largest slope. What does that graph look like? Nope. Except it has a negative x to the third, so it's going to look like that. So you can tell that if it said the smallest slope, you would say, yes, negative infinity. The slope would approach that. Okay? However, in this situation, would you guys agree that the largest slope would probably be right about there? That's the point where it's most positive. Well, could you ever draw a tangent line that would be more positive than that on this curve? If you try, you know, you're not going to get one. You know, that one's negative. So it looks like that one. So let's just think about what we're doing here. Largest means we're trying to maximize. And in calculus, what word do we use for slope? Derivative. We're trying to maximize the derivative. Do we need an equation? We have our equation. F of x equals 2x minus 6x squared minus x to the third. Okay? Are we trying to maximize that? No, we're trying to maximize the derivative. So the equation we need to use is our derivative. What is the derivative of that? Excellent. That is what I need to use. If you're trying to maximize it, what do you need to do? What did we do to all the other problems? We set them equal to 0, but before we set it equal to 0, what did we do? With every problem, in order to maximize it, we've taken the derivative and then we've set it equal to 0, right? So, oh, that's what you said? No. Hold on, guys. Hold on. And maybe you're right, but I think that you're confused. We need to take the derivative again. We're trying to maximize this. Oh, all right. So, if this is what we're trying to maximize, we need to take the derivative of this. What's the derivative of that? Okay, now we set that derivative equal to 0. So x is equal to? Now, what does the problem say? Find the equation for the line tangent. Okay. We don't have to use a calculator. Yeah, sure, we could use our calculator. M is going to tell us the slope of that line. Now, let's try to keep our thoughts organized. What tells us the slope of the line? The original function, the first derivative, or the second derivative? The first derivative tells us the slope. So, what will I plug into this first derivative? Negative 2. And when we plug in negative 2, we get 2 plus 24 minus 12. $14 is the slope. I need a point on the line. What is my x value? Which one will I plug it into to find the y value? The original. If I plug in -2, I get -4 minus 24 minus -8. -20. Can you now write the equation for the line? No, I plugged -2 into the original. So y equals -2x plus 8. What? I'm sorry. Y equals 14x plus 8. Good? Okay. Isn't that cool? You got, in order to maximize the slope, you got to take the derivative of the derivative. You like that? The slope does, in this case, happen to be at the inflection point. Yes. Yep, in this case. Well, we took the derivative, the second derivative, and set it equal to 0. We all know that when f double prime of x is equal to 0, that is your inflection point. Okay. We want to do one more today. Find the equation for the line through the point 4, 2 that cuts off a triangle from the first quadrant with the smallest area. We'll have to do the other one tomorrow. Smallest area. No. The largest area does, in this case, approach infinity. But it doesn't always. It doesn't always. Okay? So, you can always get a little smaller, and we'll draw the picture. We'll show you. This problem is really cool. Oh, it's really cool. So we've got, and there's a few ways to do this, and so you might come up with a different way, and good for you. This is point 4, 2. Okay, that's the coordinate. And it says a line that goes through that cuts off a triangle, the first quadrant, that is the smallest area. So if you could think about this, let's say you drew a line that was almost straight up and down. You get a really big triangle, right? So that's why if we draw a line like that, we're going to cut off some region, and we're going to. What's that? Oh yeah, that's what we got to make up. So, looks like the X intercept here. Let's call that point A0. I'm not going to call it 0B because we end up using B for y-intercepts. I don't want to get confused with that. I really don't know how this problem's going. Oh, we'll use K. Yeah. Yes, K is the best variable. Yes, thank you, Kelly. Yes. All right, Christina. All right, so we've got that. Oh boy, what should we do? What do we need in order to write an equation for a line? What's the point on the line? 4, 2. What's the slope? No, we won't use Pythagorean theorem in this case. We're actually going to write an expression, and Pythagorean theorem might be an option at some point, but not here. We want to be able to find the slope. We don't know the slope. We don't know what angle to put this line at, and we have to. So basically, the variable that we're going to be solving for is we just need to know what the slope is. So slope is what we're working with, but we're trying to write an expression for area. Area equals what? 1/2 times the base times the height. Now, how long is the base? A. So area is equal to 1/2 of A. Sorry. No, we're fine. What's the height? Okay. So now what we need to do is we need to write an expression for the x-intercept, and we need to write an expression for the y-intercept. How can we do that? Oh, yeah. This is gonna take a while to get through. Any ideas? What's that? Solve the area for A. Good idea. Nope, it doesn't work. Well, let's use this, okay? All right. So I'm just using this to kind of keep something straight for us. What is this? What did I just write down? Point slope form of a line. Okay. Let's plug in some important things. What is the point we know it passes through? 4, 2. So in this problem here, then we have y minus 2, right? Equals m times x minus 4. Okay? Now, everybody just hold on there, okay? All right? Let's think about it, okay? What we want to do is we want to solve for the x-intercept, okay? What is the x value? Or what's the y value of the x-intercept? 0. 0 minus 2 equals whatever your m is times. And what are we calling the x value of our x-intercept? We called it A. So now look at what I have. I have an equation that involves A, and I will solve for m. We'll have to do that for the other one as well. What's 0 minus 2? Negative 2 equals m times A minus m times 4. How will I solve for A? A0, yep. So I've got m times 4, so 4m minus the 2 is equal to m times A. How do I then solve for A? Divide by m. So what we end up with is A is equal to, in terms of m, 4m minus 2 over m. I'm going to make that just a little simpler. I'm going to divide both the 4m and the minus 2 by m. And I get 4 minus 2 over m. That's going to be easier for us to use. So I just did that for A. Now we need to do it for K. So I'm going to do the same thing. Yep, just go ahead, grab a scratch sheet of paper. So now I'm going to do the same thing over again. I have y minus, what's the point on the line? 4, 2, so we have a 2 there, equals m times x minus 4. Now this time we're going to be solving for k. Good. K minus 2 equals m times 0 minus 4, or negative 4m. Whoever said that, you're absolutely right. You're a genius. Okay, because you have a 0 minus 4 is negative 4m. Add the 2 to both sides. K is equal to negative 4m plus 2. All right, so all right, now we have 2 expressions that involve a and k, and we're going to use those expressions. We're going to multiply them together in our area formula, and then we'll just minimize it, which is easy. So my area is equal to 1/2 times my base. What represents my base? A, which is 4 minus 2 over m, times negative 4m plus 2. What should we do with all that? FOIL it all out, so we'll have 1/2 times, what's 4 times negative 4m? Negative 16m. Good. 4 times 2 plus 8. What is negative 2 over m times negative 4m? Plus 8. And what is negative 2 over m times 2? Negative 4 over m. I could combine these like terms, can't I? Get 16. So I'll get negative 8m plus 8 minus 2 over m. I just wrote the area in terms of slope. That is an amazing accomplishment in of itself. We should be proud of ourselves. You guys did great work. Now, what do we want to do? What do we want to do with the area? Yes. Half of it. Okay, so what are we trying to do with the area in general? We are trying to minimize it. That's where the derivative is equal to 0. So we need to take the derivative of that and set it equal to 0. Oh, wherever. You got the idea right now, though. The boxes at least got us started, didn't they? Doesn't really matter. Up. My diagrams are in my brain. What do we got? Minus 2 over m? Is that what it was? Okay. Now, let's take the derivative. What's the derivative of negative 8m? What's the derivative of 8? 0. Negative 2 over m is like negative 2 times m to the negative 1. What's the derivative of negative 2 times m to the negative 1? 2m to the negative 2, right? Or 2 over m squared. You're almost there. Add the 8. 8 over 1 equals 2 over m squared. Now what? Cross multiply. 2 equals 8m squared. Divide by 8. 1/4 is m squared. M is equal to plus or minus 1/2. Is the slope of this line positive or negative? It's negative. So our slope is negative 1/2. Let's go back to we're almost there. M is negative 1/2. Point on the line is 4, 2. The problem says find the equation. Can we do that? Sure. Y equals mx plus b. So y is 2. M is negative 1/2. X is 4. 2 equals negative 2 plus b. 4 equals b. Y equals negative 1/2 x. Last year's class had that problem on the test, and they knocked it out of the park. I bet you guys will all own that problem on the test. No. Yeah, there was the question of a problem, what, 5 on your... Yeah, I'll help you set it up. So if you guys want to look at problem 5, I can help you set that up, okay? Yeah. Okay, so you got this shape, right? And you got 100 centimeters square that you can use, right? So what I want to do is I want to maximize what? Volume. Volume equals good. All right, well, we're well on our way. Oh boy. This is problematic though, isn't it? Because why? Got 2 variables, don't we? We only have 100 square centimeters to use. If I want to talk about square centimeters, I need to talk about the surface area. So the surface area is equal to the area of the bottom, which is pi r squared, plus the area of the top, which is pi r squared. Oh, there's no top? Oh, okay. All right, well, that makes it nice. All right, so it's an open top, so we got pi r squared plus, we need the label, right? Now, the area of this label, the circumference times the height, because you got to wrap it around, that's the circumference, 2 pi r, times the height. Yeah. What? No, what's the surface area? So 100 equals pi r squared plus 2 pi rh. What are you trying to maximize? Volume. So we need to get rid of either r or h. Would you like to solve for h or would you like to solve for r? So go ahead. Solve for h, and whatever you get, put it in there. After you put it in there, what do? Take the derivative, set equal to 0. Well, what I would do is I would start by subtracting your pi r squared, so 100 minus pi r squared equals 2 pi rh. Then I would divide both sides by 2 pi r. So you get that. And this is the beast that you have to plug in to that. You can see you have an r squared here, and you have an r in the denominator, so one of those is going to cancel, right? And pi is just a number. If you don't know how to work with it, just turn to 3.14. But I want to leave you there because this pi doesn't cancel. That pi would cancel that pi right there, yes. You guys are so smart!